My name is Davion Burns. I'm an engineering student at Patuxent High School, and I'm going to finish my engineering pathway at the end of this year. Now, as you can see, life isn't perfect. It has its ups and downs, and sometimes people need to escape from reality. And that escape reality can be gaming for many. Gaming is loved by many, old, young, and middle-aged. And our goal for our machine is to benefit all users, all ages. But our main focus is to really focus on the population of people who suffer from depression and anxiety. Life can be stressful sometimes. Might need a little break, maybe a little escape from reality, if you will. And our goal is to offer that break for people who need it, because life is not always perfect. Our object is an arcade machine. Now, studies show that gaming releases a hormone called dopamine, otherwise known as the happy hormone. Now, what dopamine does is it makes you happy and helps you cope with the stresses of life, ultimately decreasing depression levels and anxiety levels. Now, as stated before, dopamine is released while gaming, and if our machine is a form of gaming, if somebody dealing with stress or anxiety plays our game, they will ultimately lower depression levels due to dopamine, doing our job and fulfilling users' needs.
Mental health is a serious issue worldwide, and just like how nature can provide a state of mental relief, so can our arcade machine. Mental health has never been dealt with properly, and our goal is to provide better mental health, which in turn will lead to better physical health and a better state of mind for all of our users.
We saw that many elderly people have increased depression rates, and we saw an opportunity to fix that by creating an arcade machine. Arcade machines have a positive correlation to positive mental health and are shown to improve other senses as well. Also, they also added a sense of nostalgia because old people, like arcade games. We faced challenges getting the Raspberry Pi to work, soldering the Pi along with soldering connection buttons into the Raspberry Pi. We also had unexpected fallbacks on our first trip out with the Raspberry Pi broken due to not being held in place well enough with the cords. It would overall improve our design and made our project sturdier and more rigid. Our major design choices were to make the arcade machine look like a variant of a normal arcade machine. However, with the design, we also incorporated menu buttons out of reach so that we wouldn't accidentally hit them while using the joystick or game buttons. Our model stayed relatively consistent throughout the design process. With the 3 iterations, we removed buttons and made the bottom of our arcade machine wider so it wouldn't knock over very easily with the weight of the monitor, making our arcade machine more top-heavy, so it felt as it was a necessary design change. Our prototype functions by using downloaded code onto which our Raspberry Pi, which then attaches to a functional buttons, power, and HDMI cord. It lets us display our monitor as well as play it using 2 menu game buttons and a joystick. Prototype functions by using downloaded code onto our Raspberry Pi, which is then attached to functional buttons, power, and an HDMI cord, which lets us display our game onto a monitor, as well as play using 2 menu buttons, 2 game buttons, and a joystick. This button restarts. This button is used to play the game. The joystick is used to move. This button is used to pause and unpause the game, and then this button is used to go back to the menu.
So our basic prototype functions with the Raspberry Pi, buttons, and GPIO pins. So when a circuit is closed with these 2 cables, it runs to this Raspberry Pi, which detects them and prints them out on the pinout screen. So for example, when the A button is pressed, it detects that the GPIO pins are connected and creates a closed circuit, which creates the output of A. And when I move the joystick up, down, left, or right, it all reads the outputs with these wires here. And these are soldered and protected with electrical tape so they don't touch each other and cause a problem in our circuit. And then these are also soldered. So when the circuit is closed, it runs through the Pi, and then the Pi works through an outlet we have.
In our prototypes, we used an external computer, our school laptops, as well as Clever using Microsoft Make Code to present our project inside of the cardboard prototypes we previously had. We folded them up like this and put them inside, just like that monitor there in our prototypes. We also used this to test our buttons and make sure they worked for our game.
We also added a command when you reach a certain score, it splashes the next level and changes the background. For example, there's level 3, and then the background's changed. and now more aliens are spawning. And you can see I'm at below 5 health, and that means that the aliens have a random chance to drop a heart because of the conditional statement in place that detects that the user is below 5 hearts. I already level 4, bro. I'm so cooked. There's a heart, finally. So this is the code of our game. When the game is chosen and starts, the background image will be set to the Earth. There will be a list that is set with all our alien spaceships. The user sprite will be placed on the screen and have to stay on the screen, and it will also move 100 pixels up and down depending on how the joystick is moved. It also sets the user's score to 0 and their life to 5. And this is our forever loop to continuously run the Starfield effect, so it looks like the user is flying through space. And then these are simple if conditionals that detect when the user hits a certain score and splashes what level they have reached and changes the background according to the level. And this function here, every 2 seconds, it will run these commands. So it chooses a random spaceship from our list and chooses a random location at the top of the screen and falls down at a velocity of 50 pixels. And every time the user reaches a score above 20 in our conditional statements, it will spawn another ship. And then the same for 40, and the same for 60. And every time they reach a new level, this will happen, and the spaceships will have a faster velocity to make the game more difficult. And also, when the user presses the A button, it shoots out the projectile sprite with a little effect and some music. And lastly, our overlaps. So, when the user hits an alien, it will destroy both the bullet and the alien, and also play a little sound effect. And it'll change their score by 1. And it also checks if the user has less than 5 health, and if they do, it will run this command, which has a 10% chance of dropping a heart sprite, which falls down slowly, so the user can collect it. And then, if the user does collect the life, it will destroy the heart sprite and increase their life by 1. And then last, if an alien runs into into the player, then the alien spaceship will get destroyed and shake the screen so it looks like the user was actually hit, and play a little destroying sound effect and changes their life by -1 to decrease their health. So our prototype has many flaws. For example, this bright blue cabinet that may be unappealing for many buyers. We would like to do an all black finish on our final project and then mass produce a multicolored one. And another example of a flaw we have is our wiring. So it is quite a mess because of the multiple wires you have and the lengths of wires. For example, we have the hot glue things in to keep them secure, which we would like to change by our final project. Another thing we need to do is get cheaper materials that are more efficient to mass produce. For example, like I just showed the wires, we need to find smaller wires that we can use that fit nicely into our project so they're not dangling everywhere. Also, a computer board that would secure better connections and fit easier into the control panel. So flaws we could easily fix in the prototype phase would be adding cable clips to our wires so they securely sit in here and are easy to remove instead of using hot glue. And we would also like to add a bezel around the screen so it's just the screen inside the arcade machine, like a normal arcade machine is. We would also like to add volume to our machine to immerse the user in the game and make it more enjoyable and allow them to play the game for longer